Let's learn few algebraic aspect of limits. All of this is going to help us a lot. So we have to be very clear with this, and it's very simple actually. So we're considering f and g are the two functions wherein we have the limit to exist. So for pretty much all the points, the limit exists. Okay, so when I tell this, you guys have to be very clear with what is that we're talking about. Now, with all of this understanding and all of this assumption, let's start off with the first algebra of limits, that is limits of sum of two function is the sum of limits of that function. What it means is the following. If I have two functions that is getting added, something like this, for example, sin x plus x. If I happen to apply the limits, say some constant x, and here I'm applying the limit, say x is equal to pi by 3. So what it tells us, if I'm not able to add them up, what I can do is I can take limits of the individual function in this manner. Right, I can do the same thing over here. Limit x as x tends to pi by 3. You find the answer individually and then add them up. This is what it means. Okay, this answer and this answer need not be same. That you guys can keep in mind. But yes, if you are able to simplify this further, like say we had sine square x plus cos square x, if you are able to do that, that is 1. So when we get 1, so overall the answer is 1. So if you are able to do that, then you are done. But if you are not able to simplify this further, you can do this, is what the theorem tells. Next one is to do with the difference. The same funda, what will change? Yes, from addition it becomes subtraction. Okay, next, the same funda, the addition becomes multiplication. Let me give an example over here. I can take up the same thing, limit theta tends to pi by 4, tan theta into, let me take something, sin theta. Of course, we know what we can do with this. So actually, let me not do this. We can simplify this, we know, right? Let me take it as theta only, into theta. Again, this is separate and that's separate. So what the theorem tells us, or the concept tells us, I can take the limit on individual basis, right, in this manner. Limit theta as theta tends to pi by 4. I can take this individually and then multiply them. Okay. So based on the previous thing, the multiplication aspect, we have one more theorem. So if we happen to have a constant getting multiplied with a function, so what they tell us, so they say this is a constant. Instead of g by x, we have something called as lambda. See, this is a constant, right? So a function which is equal to constant. So g of x is equal to a constant. I've written over here. How does it look like? Graphically, it looks like this. You go to any point and approach any point, it will not change. Right? If I keep doing this, nothing will happen. The output will remain the same. So when we have such a thing, by default, we know that this will result in the constant itself, lambda itself. So overall, the result is lambda times of limit x tends to a f of x. Because no matter what, the constant function remains to be a constant function. Right? For all the possible inputs, the output is the same. That's the point of a constant function. So basically, we are looking at this to be a constant function. So with this fact, we can end up with the following answer. I'll give a small example. Say we have limit x tends to 4, 2 times of x square or x cube, x to the power of 4. So I can take out 2 and then apply the limit to just x to the power of 4 or 3 in this case. This is what our theorem talks about. The same funda, but now we are looking at division. Okay, so if two things are getting divided, I can do this. This is a possibility. Let me give an example that would make it clear. So we have a limit. Oh yeah, by the way, here g of a oh yeah, anyways, we have written the condition that all the point it has to exist nothing. I'm not going to specify anything over there. Say we have x square plus 4 divided by square root of x plus 1, something like this. So I can apply the limit to numerator, take it as a separate expression, and then divide this entire thing with the denominator, root of x plus 1. And so we have the following output. All of this is must for us to write, so see to that. You guys can and should copy all of it.